Hello, good evening. Yes, good evening.
Evening to you.
Yes, so thank you for joining us. Uh, so basically, this is our Langchain framework session as part of AI engineering intermediate series. Already we had introduced Langchain framework yesterday, and we said that Langchain is a framework that simplifies the process of developing AI-powered application. So that is basically why we need Langchain. That is what we mentioned yesterday. We mentioned is ecosystem, where we said that Langchain consists of other dimensions like line graph and Langsmith. Yeah, so we differentiated between Langchain, Langgraph, and Langsmith. And actually, we said that starting with Langchain, it is the core framework, which means that if you want to build AI-powered application nowadays, Langchain is the most popular framework out there using Python. Okay, so if you're saying that it is a framework, it means that it offers or it gives you comprehensive tools for different aspects within your development. For instance, when you want to manage your prompts, as you're going to see today, when you want to create chains, when you want to have memory systems, and whenever you want to integrate your AI powered applications with other tools or other data sources. Okay. So, different from LangGraph, we said that now LangGraph, it extends the capabilities of LangChain. So it adds support for building stateful. We are going to differentiate between stateless and stateful AI powered application, multi-step agent workflow. So remember, LangGraph is mainly used when you have complex situations, within your development. So you are going to use LangGraph whenever you have multi-step reasoning, cyclic workflow, complex agents that can handle complex tasks like planning, execution, reflection of these actions. And whenever you want to have human in the loop, very, very important. Remember, as you're building this AI-powered application, sometimes we might build workflows that can pause for human approval or human input, okay? Especially if you're dealing with very critical systems in finance. And then finally, we mentioned about Langsmith. So Langsmith is very simple. It's mainly used for debugging and testing of this AI-powered application in their production environment. That's why we were saying that Langchain is so powerful because it can handle production-ready applications. So if you're saying product at an enterprise level, okay? So today, without wasting much of your time, I wanted us to dive deep into the core ideas within Langchain. So, so I want us to understand how Langchain fits into the broader ecosystem of building this AI-powered application. Okay, so you are going to see that it is designed with the concept of composability. So this means that it will allow us as developers to build complex application by just combining simple, reusable components. The philosophy behind Langchain The first one, it is the first philosophy we have there, it is composability. So so tough. Sorry for that one. So it means that you are going to focus on small behavior. Remember, for you to have a complex system, it can be built from small focused components that we can manage ourselves. We also have modularity. This is very key, especially when you want to ensure that each component has a clear responsibility. So remember, the components, you're going to call them the chains, and can be swapped or upgraded independently. Okay. Then we also have standardization in such a way that we are going to have common interface across different large language model providers and data sources. So it doesn't matter which LLM you're using. It can be OpenAI, it can be Cloud, it can be Olama, it can be Gemini. So it doesn't matter. Irrespective of the LLM provider you're using, you're going to have a common interface. So that means now we have at least a standardization of building this AI-powered application. Another core philosophy we have in Langchain is extensibility. Those English they're so tough on me. I don't know why. But extensibility means that you are able to add custom components and integrate it with existing systems. Remember, as we are building these AI-powered applications, we are also minding about already existing systems within our companies and within different areas of our working environment. I'm talking about CRMs. I'm talking about ERPs. So we are able to integrate this AI-powered application to those systems with the idea of extensibility. So we can now extend the capabilities of already existing system, from e-commerce to ERP to CRMs and so on and so forth. And then we also have observability, like we talked about Langsmith. So in such a way that there is a built-in support, for tracking and debugging the application behavior. So remember, you've deployed an AI-powered application to your enterprise systems. So there is a framework that allows you to actually monitor and track how the application is being deployed. So these are the core philosophy why we need to have Langchain framework. So we have composability, modularity, standardization, extensibility, and now we are talking about observability. So now it's good as AI engineers, we will be working a lot with Langchain to build AI-powered application across different industries. So we need to know the architecture. What do you need for you to come up with an AI-powered application using Langchain? So you're going to see that Langchain is organized in layers. So it means that each building on the previous one to provide increasingly sophisticated capability. So you start from a very small idea as you now extend the capability to other components. Okay, so at the foundation of Langchain, there are basic components like prompts. So remember, we discussed already prompt engineering. So we understand the idea of prompts. We also have LLM wrappers. This is very important. If you're talking about LLM wrappers, it is functions that can handle different large language models. So we're able to wrap OpenAI models, we're able to wrap DeepSeek models, Gemini, and so on and so forth. And then these components, they combine to form what we call chains, okay? Which now can orchestrate multiple steps. So with chains, we are able to manage. So if you're saying orchestration, it means we're able to manage the steps that we have within the Langchain. Okay. About agents and advanced applications that can make decisions and also interact with external system. So these are very key insight. I wanted you to have a look at it. It's a very key insight. It took me time to understand Langchain. So it's good for you to understand that Langchain does not replace your LLM provider. At some point, I was even asking myself, now that we have Langchain, do I need to work with replace those large language models? But rather, it sits on top of the providers like OpenAI, Anthropic Cloud, Google Gemini, so that it provides a unified way to work with them. Remember, yeah, I want to know, I don't know, anything. Just I give it a question, it gives you an answer. But for us, you want to use Langchain and then extend these capabilities of the already existing LLMs so that you're able to build different systems from them. So I want you to think about Langchain as a universal remote control for different LLM services. So if you have Langchain, you're able to work with different large language models already existing, some from Hugging Face, like the one I'm going to demonstrate today, to build this AI-powered application. One thing is good for us to know is that we have different large language models. Some are powerful. I agree, OpenAI is very powerful. Some are premium-based, and some are free-based. So it depends on the kind of service you're building. There are those services that you will need to pay OpenAI subscription. There are those kind of services that you can just build from open source. So if you're saying open source, they are free models that are hosted on this platform we call Hugging Face. Okay. So let's check this architecture. So these are the core architectures, and I want you to note them down. As you're working with Langchain, these are the things you're going to deal with in your development. So that's why you're being told here that Langchain is so specific challenge in building LLM application. So it means that if you are able to understand this component from this point of view, then we are able to effectively use this Langchain framework. So the first one I wanted you to get are the models. The models. So for you to work effectively with Langchain, you need to know what are models, what are large language models, what are these chat models? Because as I think there, models are the foundation of any Langchain application. Okay. So we have different large language models. I'm sure you've interacted with them. We have, yes, we've been talking about OpenAI models. We've been talking about Google Gemini models. We've been talking about DeepSeek. I'm sure Elon Musk has X, it's called Grok AI, and so on and so forth. So out of these models that we have, which are quite a number, if you go to Langchain, we are talking about thousands of models. I don't know how many there are here. I wanted to maintain this one, but we are talking about thousands of models already existing. Okay. So therefore, if we have a lot of models already existing, we don't need to create more models. We just need to use Langchain here so that it will provide wrappers for various LLM provider. So it allows you to switch between provider with minimal code changes. So as you're working with these models, and I want to show you that one in a very short while, there are two main types of models. Okay. We have LLMs. So they can only generate text. Okay, they can only generate text. That's why they're called LLMs. A good example was the GPT-3 models, and the other difference is chat models. So with chat models, they are designed for conversational interaction with message-based input and output, and these are the modern ones. A good example is GPT-4, GPT-5, Cloud, and Mistral, and the other ones. So there is a code sample here I wanted to show you here. Where is it? Yeah. So I've not executed this code yet because I just wanted us to get I wanted us to get the concept first so that now we move into development. So there is a wrapper called Langchain OpenAI. So we can get chat OpenAI models and so on. There Langchain Hugging Face. So we can get Hugging Face pipeline models from Hugging Face. There is Langchain. It's very, very easy for you to switch from one model to another. So for example, from Langchain OpenAI, able to work with chat OpenAI models. A good example of a chat OpenAI model is GPT-4 or Mini. Okay. And because this model is premium based, this means that at least you have to pay some subscription to use it. You will need an OpenAI API key or API token to use it. So these are the premium based model we have, which are the most powerful ones. But if you don't want to focus a lot on subscription for now, we can also work with free models. We can now get Hugging Face pipeline. Okay. So remember, Hugging Face have a lot of models already existing. So we can just say that our LLM is using the Hugging Face pipeline from each model ID. So remember, each model that is hosted on Hugging Face have a model ID. So for example, there is a model ID called I hope you're seeing that one. I've switched to the Hugging Face. Yes, now you're there. So there is a model called Crab Nano Mistral. And this is a model that you can use for text generation. So you have to specify the usability, the use case of where you are going to apply this model. So this is an open source model. It is freely available for you to use. So that's why we are passing here that we are using model ID Crab Nano Mistral. It is the main task for this model will be text generation. There is code completion. We also have text summarization and so on and so forth. And then now, as you're using this pipeline, you can now specify the maximum new token. So you can say that the maximum number of text it can release as responses is 20. So then now from there, you can give it a prompt. Like, for example, you want to ask it, Hugging Face is. So from this prompt, our response is we are going to take this LLM and then we invoke. So to invoke is to pass the prompt that you ask. So based on this prompt, we can now get a response. So that is how Langchain has simplified the development of these LLM-powered applications. So if you're talking about OpenAI, which is the most popular one in this, use Chat OpenAI. So therefore, my large language model will be Chat OpenAI. Specifically, I have subscribed for GPT-4. I would have an OpenAI API token. So then from there, you have your LLM. So already you have your LLM. So from this LLM, you can give it a prompt, like give me 3 reasons for using Langchain for LLM application development. And it's very, very similar. I hope that's why you are talking about standardization. It's the same interface in such a way that based on this prompt, we can invoke the prompt so that now we get the response and then we print it here as content, similarly to this one here. Just print response.content. It's the same. So it's the same like that one. Yeah, so we have some kind of standardization in building these LLM AI powered applications. Okay, so that is the first one. So the first one is you need to know the models themselves. Okay, so for learning, or if you're working on any project, normally you are told that you might start development with a cheaper model. You don't need to go for the expensive one. Like GPT-3 is very cheap and very powerful as well. Then as the model becomes now production ready, it's like now you are ready to deploy it into an application. You need to make it a little bit more powerful. So you can just switch to powerful models like Cloud Sonnet for production without changing your application logic. So only the model initialization code. So this is what I was talking about here. Let's say if you had started with Hugging Face free models as you started your development, maybe you didn't have the funds to pay for the subscriptions. So you can start from Hugging Face pipeline models, which are free. And then now when your model becomes ready and production ready, you don't need to change the inner workings of your code because remember, this one and this one is the same. I hope you can see there. So the only thing we can change is from Hugging Face pipeline, we can just work with, let's say, Chat OpenAI. So there is some kind of standardization. And that is what we are being told here. So you can change, we have Langchain for cloud and so on and so forth. Okay. So the first thing is models. So that's why I wanted you to research on different large language models we have. So you can research on premium ones. I think I'll give that assignment. And then you can also search on open source ones that are hosted on Langchain. And then as you do that one, you can also research on where one shines. Like I've real for documents, then OpenAI would work best for you. But if you're building application that requires calculation, requires code completion like Copilot, Cloud works better. Okay, so different LLMs have their different capabilities because their trainings were different and they were trained by different companies. Like for example, Gemini was trained by Google. Cloud, this cloud was trained by a very popular company called Anthropic. It's very popular. Anthropic. Yeah, there's a very popular company that developed, I think it's this one here. So it developed cloud. So cloud is very popular. We also have DeepSeek, the one that was built from China, and so on and so forth. Yeah. So let's proceed. So that is the first one. I hope you've noted. So I will give you a research assignment to do over the weekend because from next week we'll be now focusing on building this AI-powered application. You need to know different LLMs that are there. The ones that are free, the ones that are powerful, the ones that you can pay, how much do you need to pay? Like a good example, this cloud is very powerful, and it's very cheap to use. I think it's only like 2,000 Kenya shillings a month, and it can even do a lot for you. Okay. So now that is the first component you need. And something I'm going to show you in a short while called prompt templates. So we've already done prompts because we did prompt engineering. I hope you can recall. Now you're being told here that prompt engineering, the one that you already did, is very crucial for getting good results from LLM. So if you want these LLM-powered applications to be efficient in giving their results, then you need to understand these prompt engineering principles. So as will be using Langchain, you are going to see that it provides tools for creating, managing, and composing prompts effectively. And now on the other hand, the one we've not done so far is something we call prompt templates. I want to show you that one in a short while in a code. And prompt templates, this one here, allows you substitution. So that is the idea, making your code much more cleaner and more maintainable. So let me show you a prompt template in my code here. So I'll be sharing this one after class. So this was the code. So this is a prompt template. I hope you're seeing the prompt template could be, you are an artificial intelligence assistant. You are a financial advisor. So these are role. Remember, we had talked about role-based prompts. So within your template, you can pass a prompt like, you are an artificial intelligent assistant. Answer the question, but you don't provide the question. You substitute a variable. And that is the main advantage of working with a prompt template. You can substitute a variable. So you don't know what someone would ask about artificial intelligence. So the system knows that it is an artificial intelligence assistant. So it can be reusable. We don't know the question you are asking. And now from there, we can just say that from prompt template, I think it should be this one here. Let me, I think it should be this one. Let me just copy this one. But don't worry much about these codes. You're going to do them now starting from next week as we build this application. So there is chat prompt template, and then there's also what's wrong with this one? What's really wrong? It's okay. I think it's just taking some time. I'll get up to there. So now we are saying that our prompt. So remember, Langchain core have a module called prompts. So from module called prompts, we can import chat prompt template. We can import prompt templates, the one I'm talking about right now. And now we can say that our template, I hope you're seeing that one. So it is a prompt template from template. And then our template, we are passing the template. So the template is this variable here. So we are passing it inside our prompt. So then now we can say that our large language model, it is using chat OpenAI, GPT-4 mini, and then we're going to pass up our API key because this is a premium one. And now this is a chain. This is something that we're going to talk about in the next, where we're saying that our chain is that, so these are the chains. So remember, chains are the components. From one component, you go to the next component. So you're telling this AI that this is the chain format. From the prompt, if you get a prompt, this is actually the format, then proceed to the LLM. So we have a chain that when we get our prompt, then we are going to proceed to the LLM chain. We can have as many chains as possible. Like, for example, if you have an LLM chain, proceed to RAG, and so we can proceed to fine tuning and so on and so forth. So our chain only has our AI only has two chains. is that when you give it a prompt, then you proceed to LLM. So now, this is the question. How does Langchain make LLM application development easier? So this question is the one that we are waiting for here. Can you remember? It's the one we are waiting for here. So we can substitute it here as a variable. So that is the question. So the AI already knows that it is an artificial intelligent assistant. So it was waiting for that question. So how do you pass this question here? How do you pass it here? Let's see how that one is done. So we can just say that our question, the one we've asked, we can take our LLM and then invoke it with that question. I hope you're seeing that one. So we are instead of invoking it with a prompt, we are invoking it with a question, which is a variable. And now this is the main advantage of working with a prompt template. It allows you to substitute variable question within your prompts, like this one here. Okay, so that is what we call a prompt template. Let's go back to the definition. I hope it's the same. So remember, and I always want you to remember this one, because we can have different kind of prompt templates. So now we are saying that prompt templates allows you to create reusable prompts with variable substitution. So this one makes your code cleaner and more maintainable. So it is more maintainable because already we have an artificial intelligent assistant. So we can ask it any question we want based on the variable that we passed here. I hope you're together up to there. So that is the prompt template. And for you to design effective prompt template, that is now where you need the ones we mentioned, and they are here. So we have features like variable substitution. We have features like variable substitution. I hope you've seen that. We are able to insert dynamic values into this prompt at runtime. So it doesn't matter the templates, we can give it few short examples where we can include example inputs and outputs to guide the model. We can also give it partial variable, whereby it can pre-fill some variables while leaving others for runtime. We can also have what we call prompt composition in such a way that we can combine multiple prompts into more complex structure. So for example, if you are given a task today to build a customer email response template where you can substitute the customer name, customer issue type, the customer resolution details, ensuring that there is a consistent tone and structure across all the responses while personalizing the content. So it doesn't matter the customer, we're able to capture all the information about. So I also have one to show you few short. So remember, as we were doing our prompt engineering principle, we say that few short prompting is where you give example. You give examples to direct the LLM on how to work with the inputs. So I have that one here. I have that one here. So today I'm just demonstrating that now we are ready to write this code. So this is an example. Okay, before I give you that example, there is a difference. I hope you notice that one. We have a prompt template, and we also have a chat prompt template. So chat templates makes your LLM conversational. These are a good example of a chat prompt template. So we can say we have an LLM that is using chat OpenAI, GPT-4 mini, then you give it your OpenAI API token. Then now your prompt template is using chat prompt template. And remember, chat prompt template, you're using it from messages. So there is a difference. Chat prompt template, you use it from messages. Prompt template, you use it from template. So there is a difference there. And as you're using chat prompt templates from messages, you're able to make it more conversational. Like you can give it roles. So you can assign variables like system. So the system that we are building, as later you're going to build different systems. Let's say you're building a geography expert that returns the colors present in a country's flag. Okay? Then now you give it an example. Give it an example. So this is an example. You've told this AI model that it is a geography expert that can return colors present within a flag. How do you know, how does it know how to return its response? So you tell it that a human, so there is a system, now you're telling it that a human can give you a country like France. So that is a few shot. Actually, that is a one shot. It's a one shot. A human can give you an example like France. And then you as I, you return that France has blue, white, and red. So you've given it an example. And now, more humans will now will be providing their country. So that is a prompt template in such a way that we are going to substitute the value of the country here. So you can give it Kenya, you can give it Rwanda, you can give it Burkina Faso. So it will be substituted here. So long as now the AI already have an example on how to return its responses. I hope that together up to there. So our chain, so this one was supposed to be chain. I think, yeah, sorry, yeah, our LLM chain, that one, is we start from prompt template. And then after we've captured the prompt template, we proceed to the LLM. So that is the chain. It is a sequential chain from prompt template, we can move to LLM. So someone can give a country like Japan. So Japan will be substituted here, and now the model will invoke that country and give us the result. Yeah. So that is now what we are talking about as prompt template. So for us to be able to build effective prompt templates, we should be having the knowledge of prompt engineering principles. So let me move very fast. So that was the second one. So the first one is models. I'll give you a research assignment to do. Then from models, we need to understand the idea of how to write prompts. So this is a prompt engineering, and also how to work with prompt templates. From there, I think time has really moved very fast. We need to understand now the chains. So chains are normally referred to as, they are used to orchestrate LLM calls. So if you're saying orchestrating LLM calls, it can manage how the model interact with different components. You can orchestrate that from prompt template, you move to LLM, from LLM, you move to data, from data, you move to result. So I'm being told here that chains are sequence of calls to LLMs or other utilities. So the sequence of calls that you have are what we call chains. So they are the core building blocks for creating sophisticated applications. So if you're saying we have a very sophisticated application, it means that it might have a lot of chains. It might have a lot of calls. So these calls could be to LLMs or to other utilities. It can go to utilities like CRM, involved multiple LLM calls, data transformation calls, or interaction with other systems, all orchestrated or all managed in a specific order. So remember, there must be an order on how to make these calls. We start from prompts, Then from prompt, we go to transformation. From transformation, we do a call. Then from call, we can go to data storage and so on and so forth. So as you'll be seeing in our projects, we have different types of chains depending with the projects we have. So we have a very simple chain that is linear, okay? Linear sequence of operation. So this is the simplest one we have. Like from the prompt, you can go to LLM. From the LLM, you can go to an output. Now, as you have more advanced chains, that is now when we will need a line graph, okay? You also have sequential chains in such a way that we can pass output from one step as input to the next step, okay? Let's say you have a research assistant. It has to go fetch data. Then from that data, we have a chain to do transformation. Then from transformation, we can have another chain to have an API call and so on and so forth. We also have router chains, which are able to dynamically route inputs to different chains based on its content. This is the one I was talking about, customer support. A user have an input for customer support. So a router chain can route to different departments. Like the customer support input, maybe it should be routed to the finance department, or it should be routed to the marketing team, or it should be routed to the IT department. So you also have those router chains. And then finally, we also have transformation chains. So transformation chains are able to apply data transformation between these LLM calls, okay? So a very good example here is that you are building a content moderation chain that first classifies the type of content. So that is the first chain. From there, then routes to a specialized chain for different content categories. So it can route to news or social media content or customer review content, and then each applying appropriate moderation rules and returning structured results. So I want you to think about chains as steps that LLM take. The steps that LLM take is what we call the chain. And remember, each step has its own purpose within the LLM environment. So the next one, the memory. So memory maintains the context. So by default, most LLMs, they are stateless. So if you're saying LLMs are stateless, it means that they cannot remember the previous conversations. Langchain memory system solves this one by storing and retrieving conversation history or relevant information, therefore enabling contextual conversation and personalized interaction. So it can remember, like you have your you have a personal assistant. So your personal assistant must always remember your conversation history. It must remember. And this could be done using now the Langchain memory system. So we have different types of memory because of time. I just mentioned them, then we are going to differentiate them as we build this project. We have like conversation buffer memory that can store the entire conversation history, which is very expensive, and the other ones. So a good example, like I was talking about this one, you have a personal assistant chatbot. Personal assistant must remember your vegetarian diet. It must remember your preferred meeting times. It must remember the projects that you've been working on. So across conversation, and uses this context to provide more relevant without asking you repetitive questions. So that is the idea. We don't want to repeat asking questions. So long as you're providing us with your context, we are able to store that in our memory and always remember that one during future interactions. So I think I really wanted to stop today exactly at 8:30 because I was engaged somewhere else. So I think on Monday, uh, we will now finalize on these Langchain core concepts. And then now we start now the process of developing discussed core concepts within Langchain, starting from models, then prompts and prompt templates, and then now finally we've also discussed about chains. And that's where the name comes as Langchain. So from Monday, and memory, I think we've also mentioned memory, which is good. So from Monday, we're going to talk about indexing and retrievers. This is very, very key, especially when engineers, we are going to build AI-powered systems that will work with other companies' data. Like the companies they are working with data. So we need LLMs that can index and retrieve information based on responses. And this is one of the most powerful capabilities of a Langchain in such a way that it will enable you to work with your own. Nowhere it now understand your company policy, your company FAQs, your databases, and so on and so forth. So you're going to see how indexes and retrievers will allow us to efficiently search information through large document collection and provide relevant context to the LLM. And this is actually what it will form the foundation of what we are going to call RAG system, retrieval augmented generation system, in such a way that these are systems that can have large collection of documents, and with indexing and retrievers, it's able to generate relevant documents based on the prompt. So it will have document loader, splitters, vector store. So these are very key components. I wanted us to introduce them on Monday, then we proceed to the era of agents. And we're going to see that agents are now systems that can do operations on their own. So they can have what we call autonomous decision making. Okay? So anyone read the question up to there? And now I'll give you a research assignment, just like I've mentioned over the weekend. I just wanted you to research on different types of abilities. So with that knowledge, you're able to know that if I'm working with Anthropic Cloud, it is very powerful in doing complex calculation like data analysis, statistical analysis, and so on and so forth. So I really wanted you to do that research assignment so that at least you have knowledge and idea about different large language models. Because as you're seeing here, models are the foundation. So it means that without them, then we cannot proceed with anything. So these models are the foundation of building any Langchain application. So anyone with a question or suggestion? Or a suggestion? Anyone? Okay, so if there is no question, I'm also going to share with you this document that I've already shared if you're doing more research. And then I'm also going to give you the research assignment to do over the weekend. Good night. Enjoy your weekend. Bye-bye.